So what we're going to be trying to do in the next 25 minutes is answer two questions. What makes commercial vehicles unique, and how can we as community, that's one of the reasons we're here, advance commercial vehicle needs? Now, there's a very important point here to keep in mind that if you look at Wikipedia, what commercial vehicles mean, there's a huge spectrum of different types of vehicles. We're not going to be talking about all of them. We're going to be focusing on one aspect and just a small teaser towards the end on other parts. So that's the plan in the next, come on guys. That's the plan here. But before we deep dive into, or talk briefly about commercial vehicles, let's recapture why we're here and what's the objective of COVESA in general and this conference. And what we're trying to do mainly is really expanding the horizon of capabilities while increasing quality. We're talking about mainly software development in automotive industry. And we're doing that by multiple aspects. The first thing is, if we look at the stack that we operate within, there are multiple layers, starting with the physical layer, ECUs, sensors, actuators, base software layer, operating system drivers, firmware to a point. On top of it, we have what we call platforms, and this is actually an abstraction layer that comes to make anything underneath transparent, and more importantly, exposes APIs to applications and feature development. So from a software perspective, we're trying to march to a world where, and we've heard many talks today and yesterday about this domain, where we have APIs that we can develop applications. Those are different features that run on the vehicle. Software development and software engineers can work with these APIs rather than with the hardware implementation with the vehicle. That obviously brings a lot of values, faster turnaround, higher quality, and actually attract more software developers into this industry. And that's the main thing we're trying to achieve here. If we get into a bit more details into what I just described and examples, if you look at the commodity ECUs, this is the base, like the ECU implementation, the hardware implementation. Then we're looking at different domains, body domain, powertrain, chassis, ADAS, and whatnot. On top of it, those platforms or services that I just described, that some examples, enclosure service, lightning service, and whatnot. These are bundles of different functionalities, right? It doesn't really mean much to have them bundled, but just for the ease of use, different functionality that expose APIs. So at that boundary that you guys see there, I expose the functionality of the platform, of the implementation, underneath. So if I have a seat module, the seat goes forward, goes back, goes up, goes down. Those are APIs that I expose for software development to use. And the software application runs on top. Some of the applications that we all know, control my car, zone lighting, phone as a key, and whatnot. Those are just simple applications or complicated ones that are enabled using those APIs. And do not really know what is the hardware implementation underneath, rather than only the APIs that are exposed for that. I think you'll need to free the door over there. There are 2 seats here or 3 seats here for anybody who wants to. Now, a key point here, and we're going to be talking about it later in the presentation, is that this platform, which is my vehicle eventually, like this big boundary you can see on the slide, it's a deterministic platform, meaning that I, as an OEM, when I sell a car, I know what I'm selling. I know that there's a seat module. I know that that seat module can go up, down, forward, backward, and I expose those APIs. That thing is not going to change unless my hardware changes, and that doesn't happen very often. So I'm selling something very deterministic. I know what it is day one. Now, the APIs can be used. It can't be used. I don't know how they're going to be used, frankly, in the future. It's an evolving application that keep growing and changing, but the base implementation, that platform I'm selling, it's very deterministic. I really know what it is, and I'm exposing all its physical attributes day one. Another thing to remember while we're here at COVESA is VSS, Vehicle Signal Specification, which is a common approach for describing vehicle data. So we described how we're improving our software methodologies. Now we're talking about how we, different players in this domain, are speaking the same language, which is also another step forward into making this whole process much more easy and approachable to work with. And we can see here there's a tree. It has attributes, branches, sensors, actuators. There's a vehicle. There's a chassis, powertrain, and whatnot. You can read it. You guys have seen it. It's from the COVESA website. If you look at it, and if you look at the implementation we have so far, right, it's mainly focused in retail and mainly focused in sedans, right? That's what we have. And the focus of this presentation is obviously not on those. And the goal here is really to start looking at how we can expand those implementation. VSS is one example of it, into the new domains that are critical and important. We'll talk about that in the next slide. So let's talk about commercial vehicles. This is a commercial vehicle. Please admire the beauty. This is a stripped chassis. Ford Motor Company sells that a lot. We make a lot of money from it. We love it, we enjoy it, and we really admire its beauty. As you can see, this commercial vehicle has a steering wheel, has 6 wheels on it, has an engine and transmission, and that's it mainly. It has a network, but that's it mainly. Doesn't have mirrors, doesn't have windows, doesn't have doors. I have no idea how many passengers are going to be sitting in this vehicle, what kind of HVAC system they're going to use. I'm totally clueless. So this is a product that we sell. We sell to many people. And actually, this is a product that the vast majority of you have seen. You've drove next to it. Probably your neighbor has it in their driveway. So this is something that's very common in our streets today. Another example of commercial vehicles, and this is what the slide allowed me to fit without it looking too ugly. Police cars, motorhomes. By the way, the stripped chassis that you just looked at becomes a motorhome. Snowplowers, cherry pickers, garbage trucks, limousines, accessibility vehicles, and whatnot. There's a huge portfolio of commercial vehicles that our end users build and develop for their own needs, right? And these are surrounding us. This is what makes our life, by the way, where we are today, right? We depend on these commercial vehicles very heavily. Why are commercial vehicles important? It's like, why are we talking about it other than the aspect that it's part of our life? I have 2 graphs here. The first one is the sales in the US for commercial vehicles. If we look the years 2005 to 22, you can see there's a growth of sales, right? Commercial vehicles in the US. Other than, if you look at 2020, when there's something big happened in the world and we were limited on supply rather than on demand. But other than that, there's a huge growth into this domain. Another thing to look at is that Ford Motor Company started reporting its financials by different organizations. I have 2 here, which is Ford Blue and Ford Pro, and this is public data from Q1, though it's only 1 quarter, but this shows, so Ford Blue is actually our organization that sells, the business unit that sells mainly retail, different types of cars. Ford Pro is focused on commercial aspects. Part of its sales, just to be clear, is also services rather than only vehicles, but its main focus is commercial. Important figures to look at here is really, if you look at the wholesale numbers, Ford Pro is almost 50% of Ford Blue. And more importantly, the growth year over year is more than Ford Blue. So we are seeing that this is actually a market that's very important for us, and it's going to keep growing. Other than the money aspect of it, it brings other importances, that safety measures as an example. Now, safety is important in all vehicles that we sell. It's not something we compromise on. But when it comes to commercial vehicles, there's a small difference, that those cars are much bigger and much bulkier. It's not a sedan. In the ones I'm talking about, it's not a sedan. So it requires different types of safety measures to make sure that they're reliable and they're okay to be on the roads. Reliability, this is people's office. This is their workspace, right? It has to be reliable. It cannot break. It cannot have issues, right? It's not the commute part. They spend hours over hours every day in those commercial vehicles. That's how they make money. And reliability is more important, obviously, in these ones. Efficiency, same thing. Every dollar matters. Think about FedEx. Think about UPS. Think about all these different commercial companies that have thousands of vehicles on the street, and every dollar a day really matters for their net results. And due to the financial aspect of this, it's a very highly competitive market between the different OEMs and suppliers. We're all focusing into this. We're growing into this market. We're spending more money and more resources into it to understand really what can and can't we, how can or can't we improve this. So if you guys remember the strip chassis that we talked about, that beauty, and that stack we started with, the strip chassis and all the other commercial vehicles, frankly, that I'm talking about here, they bring a new challenge to us. And that's that physical implementation we started with, that determinism of that platform is over. When I sell a strip chassis, the vast majority of the end product, I don't know anything about it. It's, again, I know the transmission, the engine, and the steering wheel. I don't know anything else. So when I try to abstract everything underneath and provide APIs to software developers, now there's this huge beast that is part of my end product that I don't know about it. Something that my end customer is the only one that knows about it. And I still want to be able to provide them capabilities to write the right software for the reasons we just talked about, right? It's a very important vehicle that has to be reliable, efficient, and safe on the product, on the roads. So that's a challenge we need to solve, right? And how can we make sure that that question mark becomes really part of that platform? Because now my abstracted APIs do not include it, right? I can't sell it this way day one. Another thing that this product brings is new use cases that in commercial vehicles we don't have as much. For an example, driver behavior monitoring. Something for commercial vehicles important. Fleet managers and owners want to know how the driver behavior is. For retail, maybe I want to know how my kids behave in the car when they drive it, but it's not as important as FedEx, as an example. Another complexity and use case it brings is layered software updates. So I want you to think about this Frankenstein for a minute. Let's assume that it's only two entities, which is not true. There are many other entities sometimes. So that upfitted device can be many devices rather than one. And they have their software stack. I have my software stack. It's working together. Now I update my software. How do I know that it's compatible with their software? What happens if it breaks? Imagine a fleet that is shut down due to a software update that we did, right? Today, it's managed differently. Today, it's managed by, okay, let's update one vehicle and test it, and then move to the next one, and which is not an efficient way to do updates. But that's how we're managing it, right? This works. Like, we sell those vehicles and people drive them, but is that the efficient way to do it in the future or not? And that's what we're discussing. So this is another challenge that it brings, another use case of how do we really make sure that their compatibility in the different updates in the different layers that are running on those vehicles without breaking cars. So those commercial vehicles introduce an open architecture challenge, right? This architecture isn't deterministic, it's open. I have no idea what's its entities, how it's built, what are the devices, but I need to be able to serve them the right ecosystem for them to write the right software and to bring that innovation that we talked about in the first slide. That's where the challenge lies. Another thing to keep in mind, what I just described, rather than only 2 or 3 or 5 different physical implementation coming together, the need for those is driven by many entities rather than only hardware. Meaning OEMs, suppliers, commercial customers, fleet managers, insurance companies, all of these entities, they have their own use cases and their needs from those vehicles. So they can provide more input and request data from the vehicle. And that's where, due to the fact that, okay, there's lots of complexities we described here, there are physical implementation that isn't defined day one, right? It's complete towards the end. And I don't know if it's ever complete, right? Because these upfitted devices keep adding to them. Or they have the capability of doing that. An open source and data-driven collaborative environment is the key to success. Data-driven is very important. I'm not going to talk about it a lot. Ted is going to be touching base on that later today, but The only way, by the way, it's true about anything in life. Like the only way you can improve is by measuring yourself, right? So that's and we are introducing a new or current challenge with potential solutions. The only way for us to be able to improve is by really understanding how it's going and getting all the data and analytics we can get. So, and the open source part is that the fact that it has so many entities into it and requires that collaboration for it to be successful and innovation, that's where open source projects fit. That's the intention of it. Yes, it can be done in silos, but it is not efficient. It's not going to be as productive and successful as an open source collaboration. All right. So for that device to be part of the platform, right, or devices, that's our objective. We want to be able to get back to this picture where this new device that was a question mark, right, becomes a device, becomes an entity I can communicate with, that I can expose its APIs up north and tell application developers that I don't know about them today that, okay, these are the APIs and you can start writing your software, do your magic. There are 6 main phases that need to happen in some way, shape, or form. The first one is discovery. So the device need to say, okay, this is my metadata, or these are my profiles, and you can read them, you can find out what kind of device I am, or respond to identification requests, as an example. The second phase is really identification. So the device says, all right, I'm this type, these are the protocols I use, these are the APIs I can expose, and you can communicate with me using this language. Third part is where the device is actually registered as part of the platform. So now this entity that was unknown, it becomes known, and it's a device in the platform that we can start configuring, and that's the fourth phase where network authentication, firmware updates, and whatnot happen, and then we can start really working and communicating with that device, and applications can be written using APIs that will be exposed through the full platform. Testing is a key part because, again, there are many changes that can happen in any of these physical implementations. So we need to make sure that there is continuous testing, that we meet the full platform requirement. And when there's a failure, we need to highlight that before that commercial vehicle hits the road. Maintenance, software updates, ensure functionality over time, and performance. Those are the main 6 phases, while continuous data analysis is a continuous thing. It's not a phase. It has to be accompanying us all the time for us to be successful. Now, to summarize what we just went through, the main objective really here we have is to increase the spectrum of capabilities to enable developers. Our focus has been so far on retail and on sedans, but commercial vehicle is a huge market. It has a huge importance, and as we see, it's growing. So we need to start looking into this domain. It brings different challenges that we went through that are, I think, they're very interesting, and solvable. So there's a path to a solution there. Commercial vehicle brings a unique and important use case. We talked about that and the current focus. Alignment is key. So we need to be adding and configuring these new devices and exposing these new interfaces to developers. And that's a key part of being able to have this device as an integral part of the platform. I don't really see a path for this being done without a multi-entity collaboration, right? This is very cumbersome effort that has many entities into it. If I, as an OEM, gonna pretend that I'm also an insurance company and a fleet manager and a supplier, then that's not the way to do it. I cannot do that. There's no way I'll be able to do that, and that will require me as an OEM and suppliers and insurance companies and tool providers and cloud providers to be able to work together for us to be able to define those interfaces and how we're going to be building a new device and add it into this system. And when we say device, I don't want to minimize the meaning of device. Like device can be, again, you guys have seen the stripped chassis, so anything that sits on top of it. So imagine that motorhome. I sell the stripped chassis of it only. So anything that sits on top, that is part of the device. So the device can be actually much bigger than my base platform. Last bullet is very important. We're not the first to do it. The phases, we don't have to reinvent the wheel. The phases I just went through in the previous slide, I didn't invent those. Internet of Things, that's how the protocol works. That's how a new device, when you get a Philips Hue lamp and plug it into your house, and you want your Alexa or your Google Home to find it and interact with it. Those are the main phases that work. And it's a very similar problem with very similar challenges. So we don't really have to reinvent the wheel. We can really reuse capabilities that are there and bring it to automotive. So that's the good news. Navigating the open road, overcoming the open architecture challenge in commercial vehicles. That's the key message we're trying to achieve. Call to actions, see, right on time. Reuse available tools. Don't reinvent the wheel. Automotive have done that for many years, right? We've seen that there's many siloed solutions in many companies. I don't think that there will be a path to an efficient solution that brings the productivity we want if we're siloed in this one. And look into other industries. It's IoT, I just gave it as an example. There are many other examples out there that you have a new device that you plug into the system and it becomes an integral part of it. Linux is another example. There's so many other pieces that have similar behaviors. Collaborate. There are two things that are happening in COVESA that are important in this domain. The first one is, AMM today, actually, from 3:30 to 5:30, right? Not 5:50. I don't know why. 5:15? Oh, 5:30. I don't know why 5:50. I thought like maybe 50 out of 100, but okay. So 3:30 to 5:30 today. Actually, Ted is driving a session. You guys, oh, Thomas also, sorry, Thomas. With Thomas regarding this domain. There's also birds of feathers, such complicated things to say. That Ted and Thomas also are driving on Mondays, 7 a.m. Is it 7 a.m. East time or Pacific? Pacific. See, I have so many mistakes in this slide. Sorry, guys. So 7 a.m. Pacific. It's not Eastern time. It happens every other Monday, right? It's not every.
Yeah, we're going to switch to every Monday, probably very soon.
Okay. And that's where topics like this and more into commercial vehicles are discussed. Thoughts for next time, and my friends here are going to be talking about that later today, is bring retail to commercial. We didn't touch, it's like, think about Hertz. Great example from Ted, actually. Hertz is a commercial vehicle owner. They don't upfit their vehicles at all. They still have lots of needs, and there's so many things need to be done there that we're not doing yet. So the challenges I described that are related to hardware implementation, it does not mean that this whole domain doesn't have also software-only capabilities that can be done in order to improve commercial vehicles and their needs. Last but not least, start contributing. The general perspective I have on this is just don't wait for the perfect solution. Just if you think this is good enough, just push it, and the community will make sure it's actually perfect over time. And the only way we can really start advancing is by every and each one of us to start contributing to this collaboration and see how it grows from there. Thank you very much, guys. Oh, here you go, there's a question there.
I have a question. So was most of this a process you're going to follow for ICE as well as EV? Or last mile delivery, where there's this big movement right now?
Thank you. This is orthogonal to if it's ICE or an EV, right? This is a process of I have a new device I'm putting into my system, and I need to be able to expose that device and its physical attributes through APIs to software developers. So it's totally orthogonal to what kind of device it is. It can be anything. You're welcome.
Are you seeing any opportunities to use what heavy machinery industry has done with J1939 for device discovery in any of the architectures that you're looking at for commercial vehicles?
I don't know the details of J19 that I can really answer that question. So, but I'll do my homework next time. Go for it.
Yeah, so at the Geotech presentation, they were saying that they interface, they have a cloud-to-cloud interface with the different OEMs, but every OEM has different data, they have to normalize it and so on.
Mm-hmm.
Is any of these industry groups looking at commonizing it, or do you think Ford and GM and everybody's just gonna keep their data kind of looking separately to the geotabs of the world?
That's the scope of the BOF, is we're trying to normalize. We're trying to make sure we get the right data points, sampled properly in VSS and J1939, hopefully all in VSS over time. But that's sort of the initial scope, initial goal.
Yeah.
And we'll focus on commercial vehicles, or non-consumer vehicles. It's the conventions we're coming up with are, we want them to be applicable. There's already other people that are interested in other data sampling campaigns and moving things through OEM data solutions in the hub, so that we can get the right data back in the hub.
I'm glad we have the geotab rep here to answer the question. So thank you, Ted.
Christoph over there who asked a bunch of slides.
One more question. Going once. Going twice. All right. Thank you very much, guys. Appreciate your time.